Hello. In this mini lecture, we'll be looking at decision analysis. So decision problems in the area of business can come in many different forms. Some examples of decisions that will be faced are as follows. Should the company expand its sales region? How to invest one's capital? How much and what types of advertising should be used? How many salespersons should be assigned to a new territory? Or how many products should be stocked? Okay, these are common questions which we need to answer, and they all involve making a decision. So decision analysis is a systematic approach to solving decision problems under conditions of uncertainty. It's concerned with how to handle decision problems using only information that is currently available. Okay, conditions of uncertainty just means we're not certain what's going to happen. Okay, and we measure this by probability. So the first step in mathematical analysis of many problems is to translate the problem into the language of mathematics, i.e. to express the problem in terms of graphs, charts, or tables, or any other type of mathematical objects. So some important definitions that we're going to be using throughout this mini lecture. First one, ACT. And these are the options or choices that are open to us, of which we must choose one. These are referred to as acts or actions and are denoted by lowercase a. So this is what we've got to decide of. Okay, common question is which act is the best, or what should we choose? The second definition is states of nature. Now, state of nature are the events that we have no control over. The uncertainty of these events is measured by probability, and states of nature are denoted by lowercase s. And the key thing is there is that we have no control over. Okay? Use a very small example, the probability that it's going to rain tomorrow. Okay? We can't control if it's going to rain or not. So that's the state of nature. Yes, it rains, or no, it doesn't rain. Payoff and opportunity loss table. As we said, the first step is to translate a problem into the terms of a mathematical object. And here we're going to put into either a payoff table or an opportunity loss table. So a payoff table, surprise enough, is a table that shows all the relationships among the states of nature or events, all possible acts, and all related consequences. And we use payoffs, we use money, so monetary consequences. We put the acts at the top, or the states of nature, on the left side of the table. Now, decisions can also be made of a person's fear of not taking the best possible action open to him, and thus losing a good opportunity. Opportunity loss is the difference between the decision maker's profit from an act and what the profit could have been if the best decision had been made. Now, since we cannot have a value greater than the maximum, all opportunity loss must be greater than or equal to 0. Okay, we can't have a negative opportunity loss. If we do, we made a mistake. Also, one number must be the maximum. So there must be at least 1 0 in each row of our opportunity loss table. Let's go for an example. And we're going to work through this example throughout this mini lecture. A shoe shop owner must decide whether to expand his shop now or wait until later. His advisors tell him that if he expands now and the economic conditions are good, there'll be a profit of $50,000. If he expands now and there's a recession, he'll make a loss of $10,000. If he waits and there's good economic conditions, there will be a profit of $25,000. But if it's a recession, the profit will only be $5,000. So here we want to construct a payoff table and an opportunity loss table. So the first thing we've got to work out what is our acts and what is our states of nature. So the acts, remember the acts are the things that we need to choose or what our decision is. And here we say we can either expand now or delay expansion for 1 year. So there are our two acts. Our states of nature are things that we don't have any control over, and reading through the question, the economic conditions are good or they could be in a recession. Remember, these are things that we have no control over. The economy will be good or in a recession regardless of which act we choose. So we've got our basic shape of our table. There's two acts, two states of nature, so we can have a 2 by 2 table. We go back to our question, you can read the payoffs. We're told that if we expand now and economic conditions are good, we'll make a profit of $50,000. There it is in my table. If we expand now, as recession, we make a loss of $10,000. Now we want to make sure all our numbers represent the same thing. So all our numbers represent a profit. So a loss, we write down as a negative profit. So a loss of 10,000 is a profit of minus 10,000. If we delay expansion, good economic conditions, we said we'll make a profit of 25,000, and if it's a recession, only 5,000. So there I've rewritten my whole question in terms of a payoff table. It shows all the possible occurrences, okay, depending on which act we choose and which state of nature happens. So we need to work out what's the best thing that could happen. Going back to our payoff table, if the economic conditions are good, we will choose to expand now, because that would be the most we can make. We make 50,000. If we wait and delay expansion, we're only making 25,000. So the best is to expand now. If there's a recession, the best will be to delay expansion, because we don't want to lose 10,000, we're going to make 5,000. So this is important to know when we draw our opportunity loss table. So as I said, if economic conditions are good, the best choice would be expand now. If we chose to expand now, we've chosen the best act and there's no loss of opportunity. But if we choose to delay expansion, we will only make 25,000 instead of 50,000. So basically there's a loss there. We could have made 50, we're only making 25. So our opportunity loss is a loss of $25,000. Now with an opportunity loss table, all our numbers are losses. So we don't have to worry about negative or positive. They're all losses, so we write them all as positives. Using our two steps mentioned above, we can do the same for when the economic conditions are in recession. The maximum amount is 5,000 when we delay. Subtract each value from its maximum. So 5 minus 10 is 15. 5 minus 5 is 0. So here's our opportunity loss table. Okay, the basic shape is exactly the same as our payoff table, but we have our opportunity losses. You notice that we have at least 1 0 in each row, because one number is the maximum, and there's no negatives. So now, how are we going to decide which is our best? Okay, we need some kind of criteria for decision making. And there's two we're going to look at, EMV and EOL. So once we have our question written in a payoff table, opportunity loss table, we can use various criteria for selecting the best act. If we calculate the mathematical expectation of each act using the payoff table, we are calculating the expected monetary value, or more simply the EMV. Okay, E stands for expected. Now we know how to work out the expected value of a probability distribution, and this is the average. So you can think of the EMV as what's the average amount we will make if we make that decision. If we use the opportunity loss table, and once again work out the expectation, we find the expected opportunity loss, EOL. So the optimal act would be the act with the largest EMV, because we want to make the most money, called EMV star, or the act with the lowest EOL. We want to make the smallest loss. This is called EOL star. The optimal act will be the same regardless of which method we use, EMV or EOL. Okay? And really this depends on what we're given. If we know the payoff table, I will use EMV. If we know the opportunity loss table, I will use EOL. Let's go back to our example. So we want to decide whether to expand his shop or wait until later. Now we need some more information. We need the probabilities associated with the state of nature. Here we're told that the probability that there's good economic conditions is 0.6 and the probability of recession is 0.4. We want to determine what the shoe shop owner should do to maximize profit. So we can draw our payoff table with this extra column, the probabilities. Now we know that the sum of the probabilities must equal to 1. If they don't equal to 1, we've left a possible choice out. And here the probabilities do add up to 1. 0.6 and 0.4 adds up to 1. So now we can use these probabilities to work out the expectation for if we expand now, and we'll then work out the expectation for if we delay expansion. So expand now, it's 0.6 times 50 plus 0.4 times minus 10. This comes out to be $26,000. This is what we would, on average, this is what we expect to make if we choose to expand now. Let's do the same for delay expansion, and it comes out to be $17,000. we've got a choice, to make 26,000 or to make 17,000. Well, hopefully everyone agrees that we should choose the first one to make $26,000. So this is EMV star. EMV star is 26,000. This corresponds to Act 1. So our decision will be, the optimal act will be to expand now. As you can see, if the probabilities change, our act might change, our decision may change as well. If we use the opportunity loss table with the same probabilities as this example, 0.6 and 0.4, our final line, the optimal act, will be exactly the same. The numbers in our calculations might be slightly different, but our final answer will be exactly the same. Expected value of perfect information. Okay. This last example, we didn't know if the economic conditions are going to be good or not. Say if I came up to you and said, well, if you give me $10,000, I'll tell you if the economic conditions are going to be good or a recession. You want to know, is this worth it? Is it worth paying $10,000 to find this more information? And this is what we're finding here, the expected value of perfect information. So the expected value of perfect information, or as we say EVPI, is the maximum amount we are willing to pay for information regarding which event will happen. To calculate the EVPI, we need to compute the expected payoff with perfect information. So without perfect information, we know how much we will make. This is EMV star. If we know for certain what was going to happen, okay, there's no uncertainty, it was certain, we can still work out our expected value. And this is the expected payoff with perfect information. So this is the payoff we will expect with reference to a given set of prior probabilities if we were required to make a decision in an indefinite number of times and we always made a perfect decision. We always maximize the profit. So to do this, E stands for an expectation, but we just use the row maximums as the amounts. And then we just work out the expectation of the row maximums. So EPPI is how much we would make if we knew for certain what was going to happen. Okay, this is our best possible. EMV star is how much we're going to make with the information we know. So how much is our perfect information worth? What will be the difference of what we could make, EPPI, and what we are going to make, EMV star. So EVPI equals EPPI minus EMV star. Now, this is a kind of hypothetical number because we never know for certain what's going to happen, but we can think of this as our limit or our maximum amount we will pay to find our perfect information. We also notice that EVPI is equal to EOL star. So if we have worked out EOL, we use the opportunity loss, we've already got EVPI straight away because we know what EOL star is. But typically, we'll be working with payoff tables. Let's go back to our shoe shop example. We want to determine the maximum amount the shoe shop owner should pay to find out what the economic conditions will be next year. So here's our payoff table, and here I've added a new column which has the row maximums, because we've got to work out EPPI first. So we use these maximums and the probabilities, 0.6 and 0.4, as an expectation, and this gives me EPPI. So if we made the best choice every time, on average we'll make $32,000. We know from the previous example that EMV star is $26,000. Okay? So the expected value of the perfect information would just be 32,000 minus 26,000, which is $6,000. So this is the maximum we will be willing to pay to find out what the economic condition is going to be, what the perfect information is. Thank you.